Hey Calibrate Tools family, welcome back to the channel. Today we're going to learn how to build a sheet metal box specifically for a fume extraction system. And if you don't know what that is, stick around and you'll see right after this. So before we get into how to build a sheet metal box, let me give you some context here. Why I built one in the first place. This beast of a machine on the back of this trailer is a fume extractor or fume extraction system designed to expel fumes from, in this case, what's going to be a mobile welding training center. Welding produces a lot of unhealthy byproducts in the fumes, by the way. I even had to cut out a section of the trailer frame with a plasma cutter just to fit this behemoth in. Plasma cutters are really interesting and powerful tools, and we'll get into more about them in another video, so stay tuned. But to make it simple, plasma cutters channel pressurized gas like nitrogen, argon, or oxygen through a very small channel with a negatively charged electrode at the tip of the nozzle. And when you touch the tip of that nozzle to the metal you want to cut, it creates a spark that heats up the gas to an even more excited state of matter called plasma. This plasma that's generated reaches temperatures of around 30,000 degrees Fahrenheit, traveling at 20,000 feet per second, slicing through metal like butter. You would think it would go in a building, but this thing is going in a 53-foot trailer. I used the pallet jack to move the fume extractor from the back of the trailer to the front and positioned it where it needed to be. From there, I took measurements of the exhaust port, that rectangular opening at the top of it, so I could start crafting the metal ducting that would channel the fumes outside the trailer. I then pulled the extractor away from the area and began marking off the measurements on the designated area. The dimension of the exhaust port on the machine was 33¼ inches long by 6 inches tall. And after some thought, I decided to go with a configuration that would allow me to access the fasteners, that's the nuts and bolts connecting the ducting box to the machine, much easier. So I added 2 inches to the perimeter of the box, or 2 inches to each side, which brought the dimensions of the hole I would cut out to 37¼ inches long by 10 inches tall. After scribing off some measurements on a piece of aluminum sheet metal about 3/32 of an inch thick, I attempted to fold it 90 degrees on a pan and box brake or sheet metal bender, and was surprised when it snapped in two like a potato chip. The type of aluminum I attempted to bend was a 6061 alloy. 6061 aluminum won't bend because it's been heat treated in a way that won't allow it to. I needed a 5052 alloy, which I'm working on right here. So keep that in mind with your bending efforts. 6061 aluminum generally won't bend, but 3003 and 5052 will bend. Here, I'm just making sure that all my scribe lines are visible or well defined, so when I get ready to cut out the form, I don't lose track. I'm using a cordless angle grinder with a cutoff wheel to cut the shape of the two-dimensional box out. Then I'll use a flap disc to grind down the jagged edges left by the cutoff wheel. As I said in a previous video, those jagged edges can cause some serious injury, let alone smooth edges. So you should always make it a habit of grinding or sanding down these edges after cutting. Okay, so I made a sample before I bend the actual piece. Okay, I bent it and actually it worked, as you can tell, at 10 inches by 10 by 10. It barely made it. Matter of fact, let me show you here. See, I bent the first 90, then I bent the second 90, and it barely made it here, okay, at 10 inches. But that doesn't mean we're out of the woods yet. What about these side pieces? So I measured that distance from here to here and a little more to get clearance, and that's about 2 inches. So I ended up cutting 2 inches off of the perimeter of the whole piece so we can get our full 90s. So now it's 8 inches long by 8 inches long. To make sure you get a straight bend from corner to corner on your workpiece, in this case a box, you have to align opposite corners on the reference line of the bender correctly. If not, you'll get an angled bend that'll throw everything off. And the longer the distance, the worse it looks. There is some slight room for error, but I'll say that'll be less than a 16th of an inch, even a 32nd of an inch. So line things up as best you can. When bending, grab the bar, but don't raise it too fast because you might overbend. But you don't want to come up too slow either because you might lose momentum and have to stop in the middle of the bend due to the resistance of the metal. I had to remove one of the teeth here in order for me to get this side to go all the way down. The other side's going to go down there. Okay guys, I encountered another issue. When I lift it up this way, look, it hits right there. So what I have to do is I have to go shave another, I'd say another 2 inches off. That's how it goes, guys. You got to do your measurements. Some things you catch, some things you don't. I didn't catch this side. Back to the drawing board. Sometimes it doesn't hurt to take a rubber mallet and tighten up some of the bends. Just make sure you tap them in the corners where they're most stable. I TIG welded the corner seams, and though it wasn't the neatest job considering how thin the metal was, I was able to close the gaps, grind off the excess to produce a decent looking box. So here, I'm cutting out the rectangular shaped hole to put the box in. Sparks are flying everywhere, and in this confined space, I have to be careful not to be in the path of the sparks because they can cause a fire on your clothing. This cut will only take off the inner wall cut section. I have to finish it on the outside. I drilled out the 4 corners of the rectangle all the way through to the outside so I could trace the rectangle on the outside wall and finish the cut. It wasn't that cut and dry, pun intended, because I had to cut out some of the exposed steel framing of the trailer to complete the process. Here's the hole exposing the fume extractor exhaust port with 16 bolts surrounding the port. We're going to fasten the box, aka the exhaust ducting vent, to those bolts when it's all said and done. I am measuring the same dimensions as the fume extractor exhaust port on the box. Then I'll cut it out, automatically creating 2-inch flanges that will sit on top of the 2-inch extended perimeter surrounding the exhaust port that I added before. Okay guys, I gotta get that right there, up there in that hole right there. Okay guys, as you can see, I put the ducting up here and I fastened it to the area with these vice grips. Now I'm gonna take some layout fluid. Okay, it's like a blue dye. I'm gonna paint around where the bolts are. Okay, and it's gonna leave an imprint on to this. And I can use that to drill holes with. All right, I got some of them, but not all of them came through. Like down here, it's pretty smudgy, so I'm gonna have to try another method to press it against there. I got one there, got one there, but I will drill out the holes that I do have for now. I used a rubber mallet to tap the flanges against the bolts, hoping to leave an imprint on the ones I missed. It worked well enough. Okay guys, now that I got the box fitted, I'm gonna put a frame on it. I decided to make a 2-inch border connected at 45-degree angles at the corners to give it some character. So now I'm fitting it up and I'm putting rivets in, okay, while it's in place so, you know, it can fit well. So what do you think, guys? You learned a little bit about plasma cutters, metal benders or pan and box brakes, how to build a sheet metal box, how to bend it, fume extractors, right? You ever seen a fume extractor that big? We covered a lot in this video. I know it was kind of long, but I hope you enjoyed and took some things from it, okay? So if you like what you saw, please hit the like and subscribe button, and I'll see you next time.